Let's talk about something you probably have in your garage right now, sandpaper. It's one of those everyday items that often goes unnoticed, quietly waiting in a drawer or toolbox until you need it. But have you ever stopped to think about what makes sandpaper so effective, or why it's such a staple in workshops and homes around the world? It's everywhere. But have you ever wondered how it's made? Spoiler, it's not just sand glued to paper. In fact, the story of sandpaper is much more fascinating than its name suggests. The process behind its creation is a blend of science, engineering, and a bit of artistry, all coming together to produce a tool that's both simple and incredibly versatile. Sandpaper is a marvel of engineering, designed for precision and durability. Each sheet is carefully crafted to deliver just the right amount of abrasion, whether you're smoothing wood, metal, or even plastic. The manufacturing process involves strict quality control and advanced technology to ensure every piece performs as expected. Whether you're refinishing furniture, prepping a car for paint, cleaning pipes, or even working on a delicate art project, sandpaper is the go-to tool for controlled abrasion. Its versatility makes it indispensable for professionals and DIY enthusiasts alike, helping to transform rough surfaces into smooth, polished finishes. But here's the twist: modern sandpaper doesn't use sand at all. The name is a bit of a misnomer, a relic from the past when crushed shells or sand were actually used. Today's sandpaper is the result of years of innovation and experimentation. Instead, it's made with engineered minerals like aluminum oxide, silicon carbide, or ceramic alumina, chosen for their toughness and self-sharpening properties. These materials are far more effective than sand, allowing for longer-lasting and more consistent results. Each mineral is selected based on the specific job the sandpaper is designed for, whether it's heavy-duty stripping or ultra-fine finishing. And it's not always paper either. Every sheet is a three-part system: a strong backing, a powerful adhesive, and those sharp abrasive grains. The backing can be made from paper, cloth, or even polyester film, depending on the intended use. The adhesive must be tough enough to hold the abrasive in place even under intense pressure and friction. Each component is carefully selected and combined to create a tool that's simple in appearance but complex in design. Engineers and technicians test different combinations to achieve the perfect balance of flexibility, strength, and cutting power. The result is a product that can handle everything from delicate finishing to aggressive material removal. So next time you grab a sheet, remember, it's the result of decades of innovation. The sandpaper you use today is the product of countless improvements, each one making it more effective, durable, and user-friendly than ever before. Sandpaper is more than meets the eye. With a range of grits and materials, it's tailored for every task, from the roughest sanding to the finest polishing. It's a tool that adapts to your needs, no matter the project. It's a surprisingly elegant solution to a gritty problem. The next time you smooth a surface, think about the science and craftsmanship behind that simple sheet in your hand. Let's see how it all comes together, from raw minerals to the finished sheets that help us shape, smooth, and perfect our world. Every great tool starts with a solid foundation, and when it comes to sandpaper, that foundation is absolutely critical. Before any abrasive grains are added, before any cutting or shaping happens, it all begins with the backing, a material that quietly determines the performance and durability of the final product. For sandpaper, the backing is more than just a base. It's the unsung hero that supports every sanding job, big or small. The quality of this backing can make the difference between a smooth, flawless finish and a frustrating, torn sheet. It's not your average paper. This is industrial grade, engineered for strength and flexibility, specially formulated to resist tearing and withstand the rigors of sanding. This paper is designed to hold up under pressure, whether you're smoothing wood, metal, or plastic. For tougher jobs, manufacturers turn to cloth backings made from cotton or polyester. These fabrics are woven tightly to provide extra durability, making them perfect for high-speed sanding, heavy-duty applications, and even wet sanding where moisture could weaken ordinary paper. Some sandpapers use a hybrid of paper and cloth, combining the best of both worlds. This layered approach offers the stability of paper with the tear resistance of cloth, resulting in a versatile backing that can handle a wide range of tasks. For the most demanding tasks, there's fiber backing, rigid, durable, and built to withstand serious heat and pressure. This type of backing is often used in industrial settings, where only the toughest materials will do, ensuring the sandpaper won't fail even under extreme conditions. The process begins with a massive roll of this backing, sometimes weighing hundreds of pounds, loaded onto machines that control speed and tension with incredible precision. These machines are calibrated to ensure the backing feeds smoothly, without wrinkles or slack, setting the stage for flawless production. As the roll unspools, it's carefully prepped for the next steps. Automated systems check for consistency in thickness and texture, making sure every inch of backing meets strict quality standards. This attention to detail ensures that the sandpaper will perform reliably, sheet after sheet. The choice of backing determines the sandpaper's strength and flexibility. Whether it's a flexible sheet for hand sanding or a rigid disc for power tools, the backing is tailored to the job at hand, giving craftsmen and manufacturers the confidence to tackle any project. It's the first step in a carefully choreographed industrial dance, where every movement is timed and every detail matters. The coordination between machines and workers ensures that the backing is always ready for the next phase of production. Without the right backing, the rest of the process falls apart. Quality control teams inspect every roll, rejecting any material that doesn't meet the highest standards. Even the smallest flaw can compromise the entire batch, so nothing is left to chance. Now let's see how the magic really begins, as this humble backing transforms into one of the most essential tools in any workshop or factory. The journey from raw material to finished sandpaper is just getting started. With the backing ready, it's time for the glue, known as the make coat. Modern sandpaper uses high-tech synthetic resins, not old-school animal glue. These adhesives are engineered for strength, heat resistance, and durability. The make coat is applied in a perfectly even layer, monitored by sensors for flawless consistency. The type of resin is tailored to the sandpaper's purpose: waterproof for wet sanding, heat-resistant for power tools. Once the make coat is on, the clock is ticking, the adhesive is still wet and tacky. The next step? Applying the abrasive grains with timing and precision that's down to the second. This is where science meets speed. Let's see how those grains get locked in. Here's where the real magic happens, the transformation from simple materials into a high-performance tool. This stage is the heart of sandpaper manufacturing, where precision and technology come together to create a product that's both simple and incredibly effective. Instead of just sprinkling grains on glue like you might imagine, manufacturers rely on a sophisticated process called electrostatic coating. This method is a game changer in the industry, ensuring that every grain is perfectly positioned for maximum cutting power. The glue-coated backing moves steadily over a highly charged plate, while a shower of abrasive grains is propelled upward by static electricity. This isn't just for show. The electrostatic field actually pulls the grains so they stand upright, sharp ends facing out. This orientation is crucial. By embedding the sharpest points into the adhesive, the sandpaper is primed to cut cleanly and efficiently, making every stroke count. It's a detail that sets high-quality sandpaper apart from the rest. The type of abrasive grain used is carefully selected for the job at hand. Aluminum oxide is the go-to choice for sanding wood and metal thanks to its durability and versatility. It's tough enough to handle repeated use without breaking down quickly. For harder materials, silicon carbide steps in. Its sharper, harder grains make it ideal for tasks like smoothing glass, stone, or even ceramics, where a more aggressive cut is needed. And when it comes to the toughest jobs, think heavy-duty metalwork or industrial applications, ceramic alumina is the top performer. Its grains are engineered for strength and longevity, making it perfect for demanding environments. But it's not just about the type of grain. The density of the abrasive, whether it's an open or closed coat, plays a huge role in how the sandpaper performs. Open coat sandpaper has gaps between the grains, while closed coat is densely packed. Open coat sandpaper is designed to prevent clogging, making it ideal for working with soft woods, resinous materials, or painted surfaces. The spaces between the grains allow dust and debris to escape, keeping the surface cleaner and the sandpaper effective for longer. Closed coat sandpaper, on the other hand, covers nearly the entire surface with abrasive grains. This results in a smoother, more uniform finish, especially on hardwoods and metals where a finer touch is needed. Every detail in this process is meticulously controlled. From the type and density of the grains to the strength of the electrostatic field, manufacturers monitor each step to guarantee maximum performance and consistency. Electrostatic coating isn't just a technical marvel, it's the secret to ensuring every grain is perfectly positioned and ready to cut, giving you the sharpest, most efficient sanding experience possible. It's a beautiful blend of physics, engineering and craftsmanship. Each sheet of sandpaper is a testament to the innovation and attention to detail that goes into modern manufacturing. The result? A cutting surface that's not only sharp and efficient, but also built to last through even the toughest projects. Every sheet is ready to tackle whatever you throw at it. But the journey doesn't end here. There's still more to the process before sandpaper is ready for your toolbox. Now those grains need to stay put. Enter the size coat, a second layer of adhesive that locks the grains in from the sides. This coat is tough, flexible, and sometimes loaded with extras like lubricants or anti-clogging agents. Zinc stearate, for example, helps keep sanding dust from sticking. Other additives can reduce static or help with cooling during metal grinding. With the size coat applied, the sandpaper has all its core components, backing, grains, and 2 layers of adhesive. But it's still fragile, the adhesives are wet and need to be cured. Next stop, the oven. Let's see how it all solidifies. The sandpaper now takes a long looping journey through massive industrial ovens. Controlled heat and humidity trigger a chemical reaction, turning the adhesives into a rock-solid matrix. The process is slow and precise, too much heat, and the product is ruined. Depending on the type, curing can take hours or even a full day. Operators and computers monitor every variable to ensure perfect results. When it emerges, the sandpaper is cool, dry, and incredibly tough. But it's still a giant roll, uncut and untested. Next, it's time to cut it down to size and make it ready for your workshop. Let's see how it gets there. After curing, the jumbo roll heads to finishing. First, it's flexed, passed over rollers to add flexibility and prevent cracking. Then it's cut into narrower rolls or standard sheets, all with razor-sharp precision. Some are die-cut into discs or triangles for specific tools, others become continuous loops for belt sanders. Each shape and size is designed for a specific job. Even the packaging is carefully labeled with grit size and intended use. From one massive roll, thousands of sandpaper products are created. The process is fast, efficient, and highly automated. Every sheet is a result of careful engineering and logistics. Now, let's talk about why quality matters. Quality control is built into every step of sandpaper production. Raw materials are tested for strength and consistency. Adhesives and grains are checked for perfect composition. During production, sensors and technicians monitor every detail. Samples are tested for durability, cutting speed, and grain distribution. High-quality sandpaper means uniform grains, strong adhesives, and a backing that won't tear. Cheap sandpaper falls apart, leaving you with uneven results and frustration. When you buy a reputable brand, you're paying for reliability and performance. Good sandpaper saves you time, money, and effort. It's the difference between a flawless finish and a ruined project. So next time you pick up a sheet of sandpaper, remember the science and engineering behind it. It's not just a simple tool, it's a product of chemistry, physics, and precision manufacturing. Notice the uniform grains, the strong backing, and the durability. Sandpaper is a small piece of industrial ingenuity, designed to turn rough surfaces smooth. The people behind its creation are the unsung heroes of every perfect finish. It's a humble tool, but one that deserves respect. Thanks to Dave from Poughkeepsie for the great question. There's a story behind every tool we use, even the gritty ones. If you're curious about how something is made, let us know. Until next time, stay curious, and don't be afraid to get your hands dirty. See you in the next episode.